Sabotage, this is Jeff. This is a devlog for the house streams along with them. Today we're in the garage and we're going to create a Weeping Angel, or SCP-173, type enemy that interacts only when looked away from. Here's our handsy lad right here. As long as we're keeping eye contact, it does not move, but if we look away, crunch, 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 rotates to face us. Let's start by making this model in Blender. First thing we want to do is get a base mesh for just a regular human. Going to CG Trader here, searching for base mesh. The second result here will work just fine for our purposes. FBX, great, fantastic. Make sure the license is actually free for best results. Also for even better results if it's rigged, great. Then you don't have to. We can pose it a lot easier when we get it into Blender. In Blender, when we import the base mesh FBX, I'm going to delete everything that isn't just the arm for this particular design, which is arms on arms on arms. We're going to use just the arm from the base mesh. I've gone into edit mode and I've elegantly deleted everything and then sealed it off with this little lumpy shoulder here. This model already has a rig in it, so I posed it here, kind of a bend at the elbow, and then arrange the fingers as if holding an invisible orange. Like you're doing a promotional shoot for a black metal band. Lo-fi recording, pig squeals, and indeterminate forced background optional. Side note, the actual original model I got from this was called Arm for Tattoo. So if you look for a free model that's just an arm, then you don't even have to delete the rest of the stuff attached to it. In Blender here in the modifiers tab, we're going to add what is called an array modifier. What this does is it duplicates and rotates the object a number of times. If we turn this on, we can see that we have an arm that has been rotated many times. Under object offset, it says empty, but the empty is actually an object called an empty. That doesn't mean nothing. And the reason that I'm parenting the array's offset to the empty is that I can control the offset in real time in the main window here by just using the move tool or rotate. We've got G moving around. You can see that it has the cool, bizarre effect as it changes the positioning of all of the duplicates of the array. Undo that. We're going to rotate. We're using the global orientation here. So if we rotate along the blue z-axis here, you get all kinds of weird shapes. I'm not opposed to this, but after playing for it for a bit and then rotating and getting all kinds of creepy shapes, I finally decided, actually the one I wanted is the one that we have right here. All the hands are bent in towards holding an orb. The orb will be important for the puzzle as well. We're going to take all of this and export it with the modifiers included into an FBX file, import that into Unreal. Once we've imported the model into Unreal, this is what we end up with. I've also thrown a texture on it, just some cracked stone, concrete. We're going to create a creature that is a few of these stacked together. There's also going to be an orb involved. So let's go move over to the blueprint, see how I've done that. The arm statue blueprint, we look at the viewport. We can see that our creature here has a sort of double stack of these arms. One pointing forward, one pointing down, which will be sort of where it's pivoting. Also to fill in some of the space here, there's a little orb, just a little orb in the middle. This static object for rendering check is actually drawn in here, and it kind of smooths the transition between the two different copies of our arm creature. Next, let's look at how the actual logic for the rotations are happening here. The important thing is it on screen or is it not on screen? This can be determined by any number of different ways. I've decided on some line of sight checks using some raycasting. So let's check on that right now. In the event graph for the arm statue, we're doing a few different things. The relevant things for this particular devlog happen in event tick. So event tick, if you don't know, is what happens every frame. Of course, you can change it so that it doesn't happen every frame. If you want to have the tick event just be every second, every 10 seconds, you can set that in the class defaults. The tick interval in this case is 0, which is going to be as fast as the game is running, the game logic. So 60 frames a second, 120 frames a second, whatever it might be. But each tick, certain amount of real time, which is called the delta seconds, passes. This is how much has passed since the last frame. First thing we're going to do is check to see if the player reference is valid. So if for some reason there is no player that's valid, nothing happens. It doesn't complain, doesn't do anything. If it is valid, we're going to set a new rotation goal. This is a custom event that I've created inside the blueprint for the arm statue that is going to actually check if it can be seen, if the player can see it, and then also determine what is the new rotation goal that is going to set for itself that is going to lerp to. So the first check here is a line of sight check. We go in here, double clicking. We can bring up the function. This is the blueprint function that is going to determine a few booleans, true or false statements about the state of seeingness, which is definitely a real word. The line trace start is a LOS trace origin object that I have created here in the, we can see the blueprint here, just in front of the orb. The reason it's in front of the orb is that I don't want it to cast from inside the orb and accidentally get caught on some of the geometry of the orb itself. So this is basically the spot of the eye that is going to be shooting an invisible line out from to check if it hits the player. If the hit actor from the trace is the same as the player reference, then it goes into this little AND Boolean logic here. Another thing that we're considering here for this AND Boolean is if the player's position is not greater than 375, which is a way to turn off the line of sight check if you're too high above it. This is important for the puzzle. If you go too high above it, it will not be able to see you. These two booleans are combined with a logical and then are exported here in the return node as the answer to the question, statue can see player, yes or no. The second important question that this particular function is answering is player can see statue, which is an important second step. So whether or not the player can see the statue is determined by another logical AND, which is the combination of two booleans. First is the current eye state not equal to closed? Because one of the features of the game is the ability to manually control your own blinking. I have created an enumeration which has 3 different states for the player's eyeballs. Open, squinting, and close. Squinting being halfway between open and closed. These states are used to determine the effects of various puzzles, including this one. If the eyes are closed, obviously the player cannot see the statue. This is making a distinction between the player, that is to say the actual person playing, being able to see or not the statue, and the player, the in-game actor object, being able to see it or not. These are very subtly different things, but it's important to know that the player, the human actually controlling the game, if the eyes are closed, the screen is completely black, then of course you cannot see anything, so it's important to consider that. But even if the eyes are closed on the character, the player itself, the player actor can still be within view of the arm statue. A little complicated, but hopefully that makes sense. After the player's line of sight check is completed, we've got the answer to our 2 questions. The can statue see player, can player see statue? And these are directed into different paths here. The top path here, which we're not actually currently using, is a debug text path used for testing. We are also going to update the orb material. The color of the orb is determined by the state of the puzzle, which step you're on, essentially. For accessibility reasons, knowing what the color is exactly is not important. But if you can see colors just fine, then hopefully it will help to guide the player towards which step they're on. Each step of the puzzle is color-coded in this case. If the player can see the statue can see the player. But if those aren't true, that means that the statue is hidden from view, which means that the statue can become active, and then we can set a new goal rotation, because the actual act of movement is a simple rotation on the pivot of the center character. We got the statue parent. Statue parent here is what is called a scene object in Unreal. Mentioned an empty earlier in Blender. This is a similar kind of object. It is an object that has a XYZ position in space, location, rotation, scale, a transform, in other words. Doesn't have any special logic attached to it. Let's see what we got here. This is the parent of the bottom. We've got the parent of the top objects, and then we also have other things such as the orb itself, which is literally just a sphere. All these things are child components of the statue parent. The statue parent is what is going to be rotating. We can simulate here. Fortunately, I have decided to use different sound effects in game, but for now, you get this beautiful rendition. I digress. With a new goal rotation set, we go back up to the tick event. We can see what happens next. With our goal rotation, I should mention the data type, sure, while we're here. The actual goal rotation here is should just be a rotator. Yeah, it's a rotator. We got to pitch a yaw roll, 3 float values. In the next part of the tick event, after the rotation goal is set, the statue parent, the one that's controlling the orientation of all the other components, is going to have its current position, or rather its current rotation, compared to the goal rotation, and it's going to interpolate between these two values using an rInterp2 node, which, as we can, let's zoom in here, as it says here, the rotator interpolation node will smoothly transition from one rotator to another, blah, 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 blah. Essentially, this means we've got one rotation, and we have a second rotation, and every frame, it's going to smoothly transition from one to the other. The world rotation for the statue parent is set here. Then another check happens, which is the light switch overlap check, which we'll go over now. In the light switch overlap check, we're going to check the sight capsule, which we go into the viewport here. We can click on sight capsule here, which is a collision capsule that is pointing out from the orb. This, when it overlaps things, is going to turn off lights as part of the puzzle. The creature itself is a light eater, or it is just annoyed that someone has come into its garage and keeps leaving the lights on and is thus turning around slowly and trying to turn all the lights off. Whichever headcanon works best for you. If there is an overlapping actor that matches the filter of a, in this case, garage puzzle light switch, which is, as you might imagine from the name, a light switch for a puzzle in the garage, it will tell it to turn off first. It's also going to call an event dispatcher called onLightSwitchOverlapCheck. It will also pass in to this a boolean, whether it's been turned on or off, and also a reference to the garage puzzle light switch that was cast to earlier in the event dispatcher. The dispatcher here in the lower left, which we can then zoom over to the upper right to see the inputs and so forth. We have here, yes, the garage puzzle light switch and the boolean for it. This particular dispatcher is being picked up by the garage puzzle cabinet blueprint. We're going to skip over the puzzle light here and jump over here. I searched for the wrong thing. Oh no, come back. My perfectly curated tutorial. Oh no. In the begin play event for the garage puzzle cabinet looks like this. It's a cabinet and has been set into the garage, and the puzzle being whether or not it can be opened or not. This is the main thing that this particular blueprint is evaluating. In the begin play event, it's looking for different garage lights and is subscribing to the events such as on light state changed for the garage pillars that are near it. It is also taking a statue reference, which is the arm statue we've been talking about, and is binding itself to the on light switch overlap check event dispatcher, which we just looked at, so that when this happens, this event here, double click, so that when the light switch overlaps, the arm statue has changed its rotation. The garage puzzle cabinet will update the last light that it has overlapped, the reference to it. Because if we go into the actual design here and check one of the garage cabinets here, what is determining whether or not this can be opened is an expected array of lights that are on. There's a few, and there's an expected array of lights that are off. And there's also an expected light overlapping with statue. So if the statue is overlapping this particular light, which we can reference here by going click, and then zooming out. Excuse me, sir. Let me, okay, there we go. This particular one. So when all of these things are true, then the garage puzzle cabinet is set to unlocked. And then you can, as a player, click on it, open it, move on with the puzzle. Move on to the next stage of the puzzle. We'll update the light value of the orb of the creature in the middle to the next painting. Paintings being the objects in the room, which are giving the hints that you need to solve the puzzles. That's all for this devlog for the house dreams along with them. Hope you learned something about how to create an indie horror classic. The thing is still, and you look away and it changes position. A classic done in all kinds of video games. Obviously, the most common touch points here are the Weeping Angels from Doctor Who. Also got the SCP-1... SCP-173. That's another example. This has appeared in numerous video games. Of course, Sotiris from Lost in Vivo by Akamakura. Even in Remedy's Control, the refrigerator. And countless the mannequins and Condemned. The mannequins and almost literally every other video game as well. So many horror games use that as a trope. In Sound Mind comes to mind. That one was pretty cheeky. I digress. Hopefully you learned something about how you can create this kind of effect in Unreal. Different ways to do it, of course, but this is the one that this is the one that worked for me. If you've learned something, then great. If you found the way that I did something to be inspiring, fantastic. If you found something I did to be completely wrong, that also counts as inspiration. It can inspire you to go find a better way to do it. Good luck in making video games. It's rough out there. Hello, Orb Son. Can I join you in the? I can. Okay. Do you mind if I just need a? Okay. Okay. All right. Personal space. I get it. I'll just. Okay. Well, you can. Okay. You can just you stay. That's fine. I'll just. Okay. Bye.